Hello everyone again. So I will continue the recordings. So this one will be about the normal distribution. So normal distribution, and this one is the foundation of the statistics, and it is very important. So this is also called the bell curve, and this is also called the Gaussian distribution. So if you remember, we had the frequency chart in our previous slides, and that for that frequency chart we plotted the histogram, sorry, the number of occurrences. How many times does each number appear? For example, 69, it appears once, and then 70 appears again once, 71 appears 4 times. So we had this frequency chart. So if you move from a data to function, so this means that our data is discrete, so our function is continuous. So what I mean discrete by here is that so we have 69, we have a 70, but we don't have 69.5. So we are missing, or we don't have 69.3, or we don't have the 69.1508. You can see that we don't have these numbers. So what we want is that we want a function that gives us every number, so it is continuous. We don't have any gap. So this function brings us all the values in this range. For example, between 69 and 7, yes, we want something like 69.1256778. So this will be a continuous data, but in our case it is discrete. So to move from data to function, what we do is that we do the curve fit. So I am fitting a curve to our function. Hence it is not a good function. But if I increase the number of data, if I have more data, then I'm getting a little bit good function, and then I get almost I am there. I'm getting this, you can see the black colored function, okay, and that is by curve fit, okay, and that, let me just write the name of the function. That will be the curve fit. That will be by curve fit, actually, sorry. And then so we get this function, and that is called the normal distribution, or it is also called the Gaussian function. As I said, it's also called the bell curve because it is in the shape of the bell. So this function, as you will see, it is very important in our statistics, and also it's very important in our measurements. So with this in mind, so we will move to central limit theorem in our next slide, and I will talk about why normal distribution is so important in our case, and then we will discuss more about the normal distribution with some examples.